Dear student, today we discuss the assembly language programming of 8051 microcontroller on interrupt based logic. Okay, the program given here is assume that the pin 3.3 INT1 is connected to the pulse generator. Okay, this is the first important observation you need to note down. Okay, the pin 3.3, that is your interrupt pin, right? So that is the first observation. Write a program in which the falling edge of the pulse, very important. Second observation, will send a high to 1.3 whenever which is connected to an LED or buzzer based on our understanding. That means whenever interrupt occur, LED will be glow. LED will glow. So that is connected to the pin 1.3. Here, very important here is falling edge of the pulse. So what do you mean by that falling edge of the pulse? First, let me make you to understand that point. See, generally in 8051 there are two type of activation levels. Okay, two type of activation levels. To understand, you need to go for T-con register. The T-con register from the LSB side, so you can see this is the 0th bit, the first bit, second bit and third bit. This 0th bit and second bit is allocated to specify the external interrupt trigger type. There are two trigger type. One is your edge trigger, another is a level trigger. Always you please understand, interrupt will be always enabled at the transition of 0. When you are saying it's a low enable, when interrupt is, when there is no trigger, when there is no interrupt, it will be in the high level. When you interrupt, trigger the interrupt, you consider it's trigger the interrupt, that means it will be in the low level logic of 0. Lower logic of 0. That is, if you not specify, suppose if you not let me say another interrupt is edge trigger, so that is falling edge. Like a falling edge, whenever interrupt is occur, it go from the higher transition to lower transition, that is falling edge. Suppose if you want to work in edge trigger, falling edge, you want to specify in the T-con register. If you not specify in the T-con register, in default, if it default 0, it occur at low level at interrupt pin, that is low level activation level, in default. Suppose if you want to work in edge trigger, falling edge, you want to enable this pin as 1. Okay, this is for INT0, this is for INT1. If you want to work in INT0, you want to make it as 1. If you want to work in INT1, you want to enable this as a 1. Hope you understand, right? So there is a two level of activation level. One is your edge trigger, falling edge, another one is your low level activation, that is level trigger. Okay, to enable this you want to set the T-con register in specific pin, then only this edge trigger will work. Okay, so in this program they want you to work in the edge trigger. Okay, that is the main logic you want to observe. Okay, so let me go for the program. Here I have separated into 3 parts for your better understanding. It's a best is the initial program, then ISR, that is the interrupt service routine, then is main program. Okay, the first line org000h. So that means like the program start execution at the address of 00h. Okay, so it started the address of 00h. Next instruction, long jump main. Once execute this instruction, it go to the main program. See, in the main program I have started in 30H. Why I have not started in like you have a, you can see I have started 00, then I skipped to, then I started in 30. The reason is it reserves, okay, it reserves the specific memory address for the interrupt vector. Okay, the in 8051 it reserves specific memory address for interrupt vectors. Those address will fall in the span of 00 to this 30. That's why we are not using those address. So those address like a, see, the first address will be like a your external interrupt. Let me 0003H. This is for external interrupt int 0. So next is your 00013H. This is for int 1. So next is your timer interrupt 000BH. This is timer 0. So then 0001BH. This is for timer 1. Next is 0023H. This is for serial communication interrupt. Okay, this address are already reserved in 8051 microcontroller. That's why we are not using those addresses. We are starting from 30H. This is 0030H. I hope you understood, right? The next instruction you can see set B pin 3.3. That means I am configuring the pin 3.3, that is INT1 as a input. See, that's what we want to do, right? Because see, the pin 3.3 INT1 is connected to the pulse generator. That means that is a pin where your interrupt is connected. See, there only you want to perform the external action. If you press there, interrupt will be triggered. That's why I am making 3.3 as a input. Then in the next instruction, clear one pin 1.3. That means you are setting the pin 1.3 as a output, and you clear that LED at initial condition, initially off. You want to ensure that LED is initially off. Okay, this is the two reason why this instruction is coming here. Then the third instruction, set B tcoin dot 2. So this is very important. I already said here. See, this is tcon. This is a tcon point 2. Once you set this pin, it will work in the falling edge, right? You want to set this pin as 1. So that's why you can see here I set this pin, right? I will set this pin. That means your interrupt will work in the activation level of edge trigger from the low, like a falling edge 1 to 0. Then you can see you want to enable the external interrupt, right? To enable the like a external interrupt, you want to go for your interrupt enable register. Okay, this is very important. Okay, see here I have filled this value, whatever is given here I will fill it 1 0 0 0 0 1 0 0. So you can see here this is enabled, this is enabled. This should be always enabled when you work with the interrupt. If it is disabled, you are clearing the interrupts. It should be enabled 1. This is 1 is enabled. Why? Because you want to work in the external interrupt, right? That's why it was enabled. 1, rest of the bits it is 0 0, it is disabled. So that's why you can see 1 0 0 0 1 0 0 B. B is a bit. Okay, I hope you understood. Right, now you are enable the external interrupt, right? Whenever interrupts come, whenever you press that 3.3, whenever you are giving action, it will go to the ISR, that is interrupt service routine program. So you know that it will start from 0013 because we enabled INT1 interrupt, right? So it start from the address of 0013. Is the vector allocated in the 8051 microcontroller. Then see, I want to glow the LED, right? So this instruction will turn on the LED, right? This instruction will turn on the LED, right? It will turn on the LED by what is the logic? By the falling edge, by falling edge of the pulse. That is very important because you enable here tcon dot 2, so your LED will glow at the falling edge of the pulse. Then so return I, that means what? It return from the ISR and it will go to the main program. Okay, it will continue the logic wherever it left, right? So when it recognize this instruction, it will go to the main program to continue the process, right? See, it will go to this main program. So here you can see clear 1.3. so this instruction is a very important. This the logic here is like we want to ensure that the LED is off when it is not handle the to the interrupt. So that's why I'm clearing this pin 1.3. So I'm repeating again. So it is in the main loop, right? It is in the main loop. Okay, so we want to ensure that LED is off when it not handled to interrupt. When you have an interrupt means what? You are pressing. When you press only, this LED will glow. If not, in the main program we want to ensure that LED is off, right? So then if you go to the next line, so you can see short jump P here. What do you mean by that? So it will be in the loop, right? So the program enter the infinite loop, enter to the infinite loop, right, where it continuously clear the 1.3, that's turn off, and wait for the interrupt. Okay, this is your looping process. So it's keep on checking the interrupt. Whenever interrupt comes, it will go, otherwise it will keep on checking. So stay here until it get interrupt. So I hope you understand this program. Okay, here the main important is falling edge, then your register. Okay, the tcon register. Another thing, activation level. Two activation level, one is your low level, another is a edge level triggering. Okay, thank you.